Hey guys, welcome back to the Unity course. Today we're going to be talking about time because last time we actually talked about inputs and we ended up with something like this, which was fun, but you know that's not what Snake is made of. Snake is actually a game where you move automatically, say every second or every 0.5 second, and we have to actually tackle time for this to work. We have to actually talk about time to implement this mechanic. So let's go ahead and just do that right now. Now, time is actually a static class inside of Unity. If you don't know what that means, just type down time, just like this, and do a dot sign. Now, you won't see it on the video, but a lot of things actually appears here. So we have a lot of options. I'm going to just tell you the one we use the most, time.time. We use also time.delta time, and we can use time scale. Is there any other one that we use? Let me just check really quickly. This is pretty much the only one I tend to use almost in every single project. So let me quickly describe what they are. Right now, of course, this code doesn't really work, but let me just say about what they are. If I actually put my cursor over it, I also have a description, so I'm just going to read this out loud. So this is basically the time in second since the start of the game. So whenever I press on start, there is a counter starting there, so it goes up by 1 every second. You'll see how we implement it a little bit later on when we actually do this, a little bit later on in the video, so it's going to be quite soon actually. Now, time.delta time is actually the time it took in between 2 frames. This is actually a little bit hard to understand at first, but basically once you're done running, say, your update, then you actually have, you have to move on to the next frame. In the next frame, the difference in time in between that first update and the second one is actually stored inside of delta time, which means if your game is running at 1 frame per second, so that's not really cool, you're getting 1 update every second, which means time to delta time is going to equal to 1. Now, if your game is running at, say, 2 frames a second, time to delta time is equal to 0.5. This is actually super useful when you're trying to just balance your game on every single machine. So say on my hand, I would have like a super low end PC would be running the game at 2 frames a second, and on your end you would have a good PC running it at, say, 60 frames a second. Now, if we have some movement script in the update, if we have something that says snake.transform.position is plus equal to vector 3 up, it would mean that on your game you would actually go 60 meter up in a single second. But in my game, I would go up by only 2 meters because I'm getting 2 frames a second. You get 60, so you move up by 60. I get 2, so I move up by 2. However, if I take this and I actually multiply it by time, the delta time, we end up being on the same speed. So we both go up by 1 meter every single second, no matter what your frame rate is. Because since you have a actual smaller time in between your frames, then your number is going to be smaller, and you're going to do 1 times a really smaller number. If mine is always 0.5, then it's going to go up quite faster. So time to delta time is really useful for those situations. And finally, let's talk about time.timescale. Time.timescale is actually just a way to slow your whole game in general. This is going to slow your UI animation. This is going to slow all your animation. By default, timescale is equal to 1. If you want to go like half speed, then you can do time.timescale is equal to 0.5, and at this time all the counters in your game, that includes the time.time, all those counters, they go down by half. You can also speed it up by saying 2. You can play with this value as much as you want. You can do slow motion with this, you can do a lot of stuff. Let's actually start implementing it in our game, because what we need at this point is we need to have something that recurs every single second, let's say. So we're going to be moving our snake every single second. That might be a little bit too slow, so we'll just have another float that takes care of that. Maybe, say, every 0.25 seconds we move our snake. Okay, so let's start implementing this, and what we're going to be needing is here a float that I'm going to call last move. This one is going to be used, is actually going to be set every time I move my snake. So when I've moved my snake, I'm going to say last move is equal to a timestamp, which in this case is going to be time.time. So my last move would say at 28 seconds since the game has started. My other next move would be at 28.25. It would be a value that I just keep assigning every time I do a move. Now let's go say in the update, and let's just forget about this right here. We don't need it just now. We're gonna leave it there because we're gonna be modifying that code, but we won't really think about it too much at the moment. Here's what I'm going to say. If time.time is if time.time minus last move is bigger than a delta, so let's say 0.25. Okay, so I'm going to declare it up here as well. Time in between moves. So time in between moves 0.25. I'm going to say if time.time minus last move is bigger than time in between moves. I want you guys to understand as much as you can right here. So let's just mash these two numbers together. So time.time minus last move. Let's assume that time.time is at 25. So it has been 25 seconds since the game has started. And the last move was at 24.5. So at 24.5 seconds in the game, we moved. Now it's 25 seconds. So if 25 minus 24.5, it gives up 0.5. Is that number bigger than time in between move? If it is, then we're ready to move again. So if we're ready to move again, we're going to say last move is equal to time.time. And at this point, we can just reset the loop. And then we do our move, obviously. So with this logic, we can actually have something that is recurring every single 25 seconds, or 0.25 seconds. Let's have a look down here and say debug.log move. And have a look at this inside of the game. And if we just run, I should actually get that message every 0.25 seconds. And as you can tell, it's actually working quite well. So we get this message 4 times a second, and it just keeps on going like this, non-stop. Our move function is going to be based on this. Every time we get a move call, so every time we get that debug.log message, we're also going to be moving our snake depending in which direction it's looking at. However, right now we don't keep any values of where the snake is going. So here's what we're going to be doing. We're going to be modifying our script just a little bit so we can actually tell what keys the user has pressed and which direction he is going. So let's actually delete this call. We're going to go down here and start just thinking a little bit. How do we go about keeping which was the last key press? We could be storing that into 4 different boolean if you want. But a better way to do it would be to keep the direction in a vector. So let me just show you how I do that. I'm going to go at the very top again, declare a vector3 that I'll call direction, and by default it's going to equal, say, vector3.right. So we're going to be moving towards the right. Whenever the game starts, we're going to say, okay, so you are moving towards the right. Now, what is going to happen is, instead of actually moving my snake like I used to do here with those key press, I'm going to actually change the direction of my direction vector. So I'm going to say, if I press on W, then direction is going to equal up. If I press on A, direction is going to equal left. And if I press on S, direction is equal to down. And finally, if I press on D, direction is going to equal to right. Now, having this in memory, I can keep this information to actually update here. So whenever I need to move, we can say snake transform.position is plus equal to direction, which is equal to either up, down, left, or right, depending on which is the key that we press. Now, know that direction is going to be kept in memory because it is a field. It is actually a variable inside of the class. So let's actually give this a try. If I press on start now, every single second it moves in a direction. If I press on up, it changes. And it's not instant change, you know, it's not actually going down as soon as I press on the button. We have to wait until the move function is called again. Now, this speed might be a little bit too fast or too slow, depending on your preference. If you want to slow it down, you can actually just increment that value if you want to speed it up. You can decrement it if you want to go like super fast, say 0.1. That's going to be updating 10 times a second. That's super fast. Which is going to be a little bit hard for a snake game, but you know, just play around with that. Have something that you actually like, a feel that you actually like. And this is actually where I'm going to end this episode because we're actually done talking about time. Now, we're going to be using time in a lot of games. We're going to be using time pretty much everywhere. because you need to keep track of that time to have those kind of logic going on. And right now what we've done was something quite simple. There is quite a lot of other things you can do with time. You can speed up, you can slow it down. Like I said, there is such a lot of things you can do with time, but right now this is what we need, and this is where we're going to leave it here. We have our very first logic using the time. Very good step towards making our snake. We actually see it taking a little bit of shape here. And in the future episode, we're going to be talking about arrays. Because this snake is, right now, this snake is only a single cube. And it's not very appealing. A snake should be a little bit longer. So we're going to be talking about that inside of arrays. And guys, for now, this is where I'm going to end today's episode. Again, thanks so much for watching. Leave a like on the video if you enjoyed, if you learned something. And also support me on Facebook, Patreon, website, all the kind of stuff. If you can share it around, would help me quite a lot. And that's about it. So thank you so much for watching, and I will see you in the next one. Cheers.